I wanted to follow up on last week's video where we were writing the Senet board game. We didn't have a chance to finish the game last week, so I thought I would write a couple of functions this week to move us further along. Now, we're not going to be done with the Senet game by the end of this video, but at least we will be further along, and I think you can see how the rest of the game would come together. Now, to get started, I want to be able to write a function that will simulate throwing the throwing sticks. You remember that in Senet, you got these 4 throwing sticks. It's white on one side, it's black on the other. And you're basically throwing them, and it's the number of sides that are white that indicates your move. And if you think about that, it's kind of like throwing or flipping a coin 4 different times. You're basically looking for a heads or a tails, a black or a white, or if you think about it, a 1 or a 0. It's binary. Now, there's a couple of different ways that we could do a function to do throwing sticks. We could do a function that stores the data in a struct of 4 different sticks, and as it throws these throwing sticks, it could do a random number, and it could determine if it's odd or even, and that determines if that stick throw is a 1 or a 0. But since it is a 1 or a 0, we actually could write a single function that stores all of those 4 sticks in one variable as a bit pattern, 4 bits at the end. So let's write a function that does that. So I'm going to do this. I don't need to update my Senet game. Let's actually write a different thing here. We'll do this one as, we'll call it sticks.c, just to write a standard function. We don't have to get lost in the details of doing this as a con.io program. So let's do something that we're going to do print out to a standard output, which means I need standard IO. And I'm going to do random numbers, which is in standard lib. And let's do a function int throw sticks. And no argument taken to this one, so it's just a void. Now we're going to do something that's going to, as I said, it's going to simulate throwing 4 throwing sticks and store the results as a bit pattern. And so that means we're going to store and hold on to 4 of those bits, the last 4 of the bits. So how do we write this? We're going to need something that's going to store a random number. So we'll do an int here for, we'll call it R&D. And then let's go ahead and pull that random number. And that random number is going to be just using the random function. Now, random is going to generate a different size value than an int. So let's actually do a variable cast to an int. And how do we grab just the last 4 bits? Well, let's remember that binary goes like 8, 4, 2, 1. Actually, it's usually got some bits off to the left there. So what is that doing? That's the 1's place, the 2's place, the 4's place, the 8's place, and 16 will be off to the left, and then 32, then 64. Right. So it's you're looking at every place is twice what it was before. It's basically it's 2 to the n is really what that is. So what if I'm just looking at those last 4 bits? A binary 1111. What is a binary 1111? Because I need to do a binary AND to capture this. So that's going to be 8 plus 4 plus 2 plus 1. And that should be, if I'm doing my math correctly, that would be 15. And so that means to mask that off, to store that bit pattern, I don't have to store, I don't have to mask it. I guess I could just return it as I have, but I just want to guarantee that I'm only really looking at those last 4. So I'm going to do a return of a value that is a random number, the random number that we just pulled, binary and with 15. Now, as I said, I don't need to do this because I could just say, look, I'm just going to use the throwing sticks and I'm just going to pull a random number and only pay attention to the last 4 bits, which actually makes sense anyway. And the rest of it will be noise, but I'm being clean. So I'm going to do this as using a bit pattern. Also, another way to demonstrate how to use a bit pattern. Now let's do our main function just to kind of test it out. I don't have any arguments to this. So how do I test this? Well, we need to have a variable to store the results. We'll call that one throw. Now we need to always seed our random number generator. Right? We need to do sRandom, and if you remember in other videos we've been putting in some number to seed my random number generator. I don't want to do that this time. Let's actually make something that's going to always be a new random number every time we run the program. If you do a static number there, you're always going to get the same series of numbers. So let's actually pull something from system time. And we're going to do that using the time function, and we're going to pass it the value of null. Now, normally the time function is going to return in a big number that's the number of seconds since the system's epoch. There's a different epoch for DOS as there is for Unix, and I'll leave that for you to look up on your own. But basically, you're returning a very big number. That very big number is going to be a variable type of time t, but that's not what we want. We actually want to we need to seed the random number generator with an unsigned integer rather than time t. So just to guarantee that we're putting in the right value, we'll just do unsigned int, and that's our variable cast. And then let's go ahead and capture the random number, throw sticks, and let's go ahead and print it out. Printf. Now I'm not going to print it out in binary yet. We'll write that in a second, but just so we know that we got a number, let's print out the throw. And I can return back the operating system. Now before I can compile this, time is not in standard lib. It's actually in another header file called time.h. So I need to include that as well. So let's go ahead and compile this program. I can just compile this with the GCC compiler. So i16 GCC. We're going to turn on all warnings. We're going to save this as sticks.exe, and we'll compile the sticks.c program. And if I didn't make any errors, then it should just be quiet when it comes back. And now I can run sticks. And you can see it's generating 1, 0, 0, 10. So we are pulling up different numbers here. And these numbers will all be between 0 and 15. Why is it between 0 and 15? Because I masked out the bits. The bits will only be between 0 and 15. So every time we run that, we're pulling up a different bit pattern that's only varying those 4 last bits. Now let's write another function that actually shows the bit pattern. So let's go ahead and write sticks.c. So let's do another one here. And we'll call this one show sticks. So int show sticks. Now I should actually give a value here, which will be sticks. That'll be the value that we're going to give it. This is the throw, in other words. Maybe I should be using the same variable name, but remember, variables are local, so we can actually use different variable names if we like. And remember that the binary pattern is the last 4 bits that we're paying attention to, and so that means the mask binary goes like 8421, and that means the mask value here we're using is 15. So let's create a variable that's going to display the results. So we'll do a character display. We'll just call it display. And let's give it some markers that I'll use here. We'll put a marker here for our sticks. We'll space them out with a space in between each. And then if we were to use this in a program, we probably would print this multiple times. So I probably would have a function to do that, but we'll just leave it as is. So let's pull up our bit patterns. Let's actually fill in each part of the display for each bit. So let's do the first one. So again, remember that binary goes like 8, 4, 2, 1. So that means the first one, we'll call it here the the first X. I suppose we could do it the other way around, but we're going to do this actually in the order that we see it. So we'll do display 0 because that's the first letter in our string is going to be sticks, which is what we just passed in, and only looking at the last one. So I want to do a binary AND to just pull that last one. That's 8. And if it's, so I could do this as an if, but we're going to do it inline if because it's only a very short thing here. So if that value is true, question, what's it going to print? So we could print a 1, or if we're displaying this on the screen, we might display a vertical line to indicate that that's the that's the white side. But actually, let's use a graphical display character. So the DOS extended character set, we can use 333, which should be a filled box if I'm remembering this correctly. And if it's not true, if that throw is if that bit is not a 1, we could put in something else. So let's put in a slightly different character, and we'll see what it looks like here in a second. But we'll put in 263, and then let's rather than having copy and paste it, or rather than have to type that all the time, let's copy that, and we'll just paste it in here a couple of times. So I want to do just go down the list here, and we'll do 4, 2, and 1. And what were my positions here? This was position 0, position 1, position 2, position 3, position 4, position 5, position 6. So I want to do 2, 4, 6. And so that's what I'm doing. Let's go ahead and now print that out to the screen. Now, if I were writing this as part of the rest of the Senet program, I probably would pop up a window or put something on some part of the screen. But here we're just going to print out what that looks like. So let's do a put s because it's just a string display. Oops, display. And because I like to have you know what? I was going to return something, but I don't need to. There's nothing to return, so let's make that a void. So all I'm doing here is I'm grabbing a variable that I'm going to pre-initialize to be the right size, and then I'm going to go through the binary of my sticks, since I'm only looking at the last 4 bits, and then replacing each one of those X's with a special character. And that's what I'm doing. So rather than doing my printf here, I can do another function that just is show sticks and then give it the throw value that we just ran. So now if I save and quit and then I16 GCC, we'll turn on all warnings. We're going to save this as, again, sticks.exe. I'm going to compile the sticks.c file. If I don't have any warnings, looks like I don't, I can go ahead and run sticks. And so you can see that it's generating a vertical line, a nice little drawing line. If it's a 0, and it's a full if it's actually a 1. So you can see what my throwing sticks actually look like. And if we're going to draw this in, here, we'll just do one more time here. If we're going to draw this on screen, we'd probably want to put that in so it's taller rather than just 1. So I probably would want to have another variable in here called, we'll do it as row. And then rather than do just a single put s, we'll do a for row equals 0, and then how many rows do I want to display? We'll say we'll do 4 rows. Row less than 4, and then row plus plus. and that would do the display. Now, what I'd probably be doing in my actual program, if this were using Con.io, is this would be just advancing to different rows within some little message box or something. That's just the right size. But here we're just going to display a little bit more of what we're looking at, where we compile our program, and then we just run the sticks program. You can see it's making it a little bit taller. That's all we would do, just so it looks a little bit more like, you know, a throwing stick. Maybe 4 is too tall. And so that's what how we would throw the throwing sticks. Now let's do something that actually would calculate how many spaces we can go based on that throw. So how would we write that function? So let's do fed sticks.c, and then what does that actually mean? Well, we need to look at the number of bits that are yes, basically the number of sides that are white. So we're going to have a function here called Mymove, and then we'll take in the value of the sticks. So remember, the bit pattern is always the last 4 bits. And that means it's going to be like 8, 4, 2, 1. We're going to see that a lot here. So I can evaluate each stick as a 1 or a 0 in each one of those positions. So let's do that. Now I could do that up here by, you know, copying and pasting what I had done up here, and using the masking that I had done on the right hand side of the equals. But let's do a for loop. So let's do int n moves, right? I need to figure out how many moves I have. Let's sort of initialize that at 0. And then let's do a shift. We're going to do a bit shift. Again, why am I doing a bit shift? I could do it in any number of ways. This is just, I want to show something that's coming from what we learned in the series. So we'll do a for loop on here for shift starts at 0, and as long as the shift is less than or equal to 3, because if we look at where we are here, we're going to start with a 1, and then we're going to shift left by, that's 1 position, left by 2 positions, left by 3 positions. So shifting is less than or equal to 3, and then we're going to add 1 to the shift. So if the sticks throw binary and with a 1 shifted that number of spaces. So remember, a 1 shifting 0 is just a 1. So that's okay. And if that's true, then I'm going to add 1 to add my moves. And I think that's all I need to do, because all I'm doing is now is shifting through those 4 bits. So let's go ahead and do that. And we'll go ahead and return n moves. And now in our program down here, we're going to actually show, let's do a printf, I can move that many number of spaces, right? That's my move. And then let's actually pull in the value here, which I just now realized I don't have a variable for. So we'll do int, we'll do n moves. Sure. And then the value is n moves. Oops, n moves. And I probably should then pull n moves is, was it my move? Is that the name of the function? Throw. And that should be our program. So let's go ahead and do that. And compile that program. If I don't have any errors in there, I should have a quiet compile. And now I can run sticks. And so here we have 2 white sides showing, and that means I can move 2 spaces. Do it again. I have another 2 white sides showing, and that's 2 spaces. Do it one more time. And the left 2 are white, so I can move 2 more spaces. I want to do something to at least have more than just 2, like 1 or 3 or something. There we go. There's a 1. So the left side, only the left one is showing white, and that means we can move 1 space. So this is a function that just very simply wanders through the bit pattern to figure out if we can make a move or not. Now, another function that we can write to determine if we have a valid move. So if we, as we make our selection, remember the Senet program here, as we use the plus and the minus to go left and right, the move that we're trying to make, we need to hit space to select, and so we need to be player A, and so I would say, hey, I want to do that. Well, how would we know if that's a valid move? Well, we would need to have a function that does that. So we're going to do a function here. We'll just stick with that sticks file. So we need to have a function that figures out if a move is valid or not. So let's do an integer function that's isValidMove. And then for that, we're going to need to pass it the board, which you remember was an array. And so we'll do int board. And then whatever player I am, which is a 1 or a 0, or a 1 or a 2, int player. And then what the move is. So we'll do, that's the move that we're going to do. And then what square am I starting from? What square did I select on the board? From 0 to 29. So let's remind ourselves here what the board looks like. So the board will look like, it goes in a backwards S. So you've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I didn't leave myself some space there because I know I'm going to need that. And then the next row goes backwards. So you get like 19, 18, 17, 16, 15, 14, 13, 12, 11, 10. And then on the last row, it goes forwards again. So we get 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29. So that's the 30 squares that are on the board. And let's look at what we're trying to do here. We're trying to do one to see. Well, it would be kind of dumb to allow like a 0 move. That would be kind of stupid. So let's block that. So if the move is 0, then that's not a valid move. So we'll do return 0. That's a easy one to start out with. Now the rest of this function is going to really encapsulate most of the rules, right? So this really encapsulates all the different rules that are in Senet, because this is telling us if a move is valid or not. And so to do that, we're going to do a switch statement. So we're going to do a switch on the square that we're looking at, because remember, there are different squares that are significant. On the last square, so on the 29th square, remember we could only allow to move 1. That was the 1 square. So if I'm on there, I can only move off if the move is 1. So if move is 1, then return true. And otherwise, we're going to return false. And we'll just use that 0 and 1 value. Probably don't need a break here because I've really guaranteed a return, but we'll do it anyway because I'm used to it. Now the space before that on 28, that is the 2 square. Yeah, we'll just do that. Just to stub in some more here so we can remind ourselves what they are. The 27 square, that was the 3 square. We shouldn't actually have a 26. Because we can never start there. Remember, 26 was the trap, And so if you go off, if you land on 26, you resurrect on 14. So we don't need to have a case for 26, but we do need to have a case for 25 because that is the stop here square. I don't think we had anything else, so really it's just any other square on the board will be the default. So let's look at 28. So for 28, that's the we need to basically do the same logic that we had on case 29. So if the move is 2, then return a true value. Otherwise, we're going to return a false value. And then, again, I don't need a break. We'll just do it anyway. And then same thing down here, but it's for 3. So if the move is 3, then return a true value. Otherwise, we're going to return a false value. And that stop here square. Okay, so that one, we need to verify if it's a 1, because we got a couple of things here. So let's actually think about it. If it's a the move is a 1, we need to check is anyone on the resurrection square. Remind ourselves up here what was the resurrection square. Let's just go ahead and cut and paste this entire thing down here. We'll do cut and then paste. Let's put it right here. So is anyone on that resurrection square? Resurrection square, if you remember, that was the stop here square, and the resurrection square was right above it, so that was number 14. So is anyone on that resurrection square? And if it's the other player, so if board 14, actually if anybody's on there, really, so if board 14 is greater than 0, actually it's a true or a false value, so I could just say if board 14, but here we'll just say if it's greater than 0, then nobody can make that move. So return a false value. Otherwise, if that's empty, so else, return a true value. And so that's what that really means, is that if anybody's sitting on it, then we can't make the move. And if nobody's sitting on it, then we can make a move, because it means that we're going to be making our move. Now, remember, it's throwing sticks only go up to 4, and so if we were on 25, the stop here square, a 1 would bring me there, which resurrects me on the resurrection square. A 2 would bring me over here. A 3 would bring me there, and a 4 would bring me there. So I don't have to worry about what happens if I exit the board from square 25. It's impossible. We have some stuff before that. We have to guarantee that we can stop on 25. So we actually do have some stuff before we can do the default, and that's case. What's coming up before that? 24, case 23, case 22, and case 21, right? Those are all things that if I'm on 21 and I get a 4, 1, 2, 3, 4, that would stop me exactly on 25. So I need to see if that move is going to bring me, it can only bring me up to or exactly on square 25. I can't go beyond 25. I could do a separate math for each one of these, or separate if block for each one of these, or I could just do some math. So if my move is, let's say, less than or equal to 25 minus the square that I'm on, I think that's what the math does, right? So we can return, you can't, that's a true value. We can actually do that one. Otherwise, return a false value. You can't actually make that move. So let's make sure that actually makes sense. Let's say I'm on 23, and I have a move of 3. So 3 less than or equal to 25 minus 23. Well, that's 2. So nope, that would be a false, because that would be down here. So okay, so this works. So if I've got that's the correct math. And so after that, I need to do a break. And what comes before that? I don't think anything comes before that. So if I'm down here, I need to see if there's a capture. So the rest of the board, check for a capture or an open square. So let's I think I'm gonna have to use the other player value a couple times. Let's look at other player. Let's do an integer definition up here, and we'll call it int other player. So I'm going to need to look at what is the other player from me. So if the players can only be a 1 or a 2, that could be done with just a regular if statement. I could do some math on that one. I guess I could do 3 minus. But let's not be too clever. Let's just do other player equals, and then we'll just do an inline if. So if player is 1, then return the value of 2. Otherwise, it's going to be 2, so you need to return 1. So that tells me what the other player is right there. So let's check if a capture. So if the board at position square plus move is the other player, that's a good one, because that means I can do a capture, right? So that indicates a capture. So I want to return a true value. Probably should do something to indicate back to the calling function that this move is a capture. So let's do a -1, which is still a true value, if I can make that move, but it's a capture. So let's do that. Otherwise, if the board at position square plus move, oops, misspell, square plus move, is me, then that doesn't make sense. So that should be, you know what? That doesn't make sense. No point in testing for that. If that position, though, is a 0, that means it's an empty space. I can do that. So let's return a 1 on that. I don't see any other conditions that I can really have, right? It's either, oh, actually, yeah, the space that I could be moving into is myself. So otherwise, return 0. I can't make that move because there's no point in capturing with yourself, right? There's no point in doing that. That should be that. And if nothing else has happened, that's the last thing in my switch statement. I think everything will have been captured here, but just to do, I'll just make sure that return 1, right? If it's been captured up above, it's probably a valid move. Although I think everything has a return value, so actually that last return, nothing should really get there. Yeah, everything's got a return value. So that last return value is completely meaningless. I'll just put in a comment here. Should not reach this point. And there we go. So let's actually test this in some way. Let's store integer board, and that's 30 spaces, 0 to 29. And let's, oops, what am I doing? I thought I was in the main function. Where's my main function? There it is. Let's do integer board. Again, 30 spaces. That's going to be from 0 to 29. And let's fill it with zeros first here. So let's go ahead and fill it with zeros. So for I equals 0, I is less than 30, I plus plus. And then we're going to set the board to, at that position, we'll set it to 0. Let's be smart with our variable names. Let's not use I, let's use square. And you know what? I actually don't need to start at 0. I can start at 1, because right before that I can do for square equals 0, square less than 10, square equals square plus 2, or remember we could do it as square plus equals 2. And that then I can say board at position square is player 1, and board at position square plus 1 is 2. And that makes sense, because now I'm filling up the first 10 spaces, and then I'm filling up the 20 spaces that follow it. Let's go ahead and print out what our board looks like. For square equals 0, for square less than 30, square plus plus. And we're going to do a printf on the value of that square and then a space after it. And then we'll close the loop. And I probably should do a new line at the end of that. And so then it's going to throw my sticks and tell me if I can, what move I'm making. And let's say, let's do something that actually figures out all of our space. Well, let's look at the first one. So let's test the logic of the is that valid, right? Is valid move, I think we call it. So if is valid move, and what was the how did I call that one? I called that one with the board. I wanted to pass it the board. Oops, the board, the player. So let's say player 1, and the move that I'm making and moves, and then what square am I looking at? Well, let's look at what's the last position that they're going to be on. So if we go back and think about what that square or what that board looks like, remember that player 1 is going to be on the odd numbered pieces. So 0, 2, 4, 6, and 8. So let's look at the last position. So let's actually just hard code this. We'll just as a test. And we'll just say put s. Do a printf actually. Printf. I can move that number of spaces from square that. Oops, present d. And that's the n moves and at position 8. And then since we already know what it is, let's hang on. I've already got it written down. Let's keep it here. And then otherwise, it's going to say printf. I can't make that move. So let's go ahead and we've now written a very long function about if something is a valid move or not. So let's go ahead and look at if that compiles. So I want to compile with GCC. And if I don't have any warnings or errors, and I should get a clean compile, and I knew I'd have something wrong. Looks like I am missing Oh, and the very last part of my my file looks like I forgot a parenthesis. So let's go ahead and edit that down to the bottom of the file. And yep, right here I missed a paren. Save, and let's go ahead and recompile. I think that was the only error that I saw. Something is wrong here. Line 180. In function valid move. Oh, do I not have... Oops, I just recompiled. Do I not have invalid move closed off? I've got invalid move closed off. Did I mess something up down below? Mymove, that looks good. So, do I have anything in there that's broken? I don't see anything obvious. From that error message, it looks like there was something that was missing. Like a forgotten closed curly brace. So I'm going down and checking to make sure that all of my curly braces that have an opening. Oh, and there it is right here. If move is 1. That was the stop here square. Any other one, we should probably look at the other moves that are possible on there. So yeah, let's check if the is it a capture or is it moving forward? So I got logic down here for that. So I could actually, the smarter way to do this is to say, let's move these, cut, and we'll put that right up above the stop here square. So what am I doing? I'm being very clever. I'm hoping I'm not being too clever. This is saying on the stop here square, from the stop here square, if I'm moving 1 position, that will be the trap square. And you have to resurrect on 14, and that's why I've got a test in here about if somebody's on 14. Now, if it's not a move of 1, if it's a move of 2, 3, or 4, I'm going to end up on those special squares at the end. But it turns out I've already got logic on here that says for the rest of the board, check for a capture or open square. So if I don't have a break right here before my default, then if this if statement didn't return, which it has here, or it'll do a break. I don't need a break there actually. If it doesn't return, then it'll hit the end of the if, and that means if the move was not 1, then it will not find a break and it'll move on to the default. It's a way of inserting a statement, and now we've got logic there that says, can this is this a capture or is it an open square? And so I think that should do what I need it to do. So let's go ahead and compile that and see if that also got rid of our warning or our error. It looks like it did. Now let's see if everything else was right. Sticks. So from square 8. So square 8 is that last one before that 2 and then the zeros. And I could make a move of 2. So I could make two spaces moving from square 8. Let's try again. Again, another 2. And a 4. Yes, obviously I can move that one. I'm hoping I pick up a 1 here without too much delay. There we go. There's a 1. And I can make that one as well because that is a capture. And if I wanted to, I could test this function. Probably would be the best idea to test this function by hard coding in different values of my board. But I'm going to move on real quick, and I'm going to show one other function. So now that I've written that, where it tests if any one particular move is valid, I want to test something else. I want to test if there are any valid moves for me. So now that I've already got this thing up here that says, I just passed it here, a function that says is valid move, let's write another function below it that says int do I have any valid move. So just say any valid move instead of is valid move, any valid move. And again, I want to pass it the value of the board. I want to pass it the player. Oops, probably should tell that it's an integer, integer array board. And then what player I'm at. So player, and then what move I've got given. I don't need to put in the square here because I'm looking to see if there are any valid moves. So we need to look at all the squares. Because now that I've got a function that checks if a particular move is valid, I can just iterate through the squares. So we're going to loop through the squares to check all possible moves. So what's the easiest way to do this? Well, we're going to do a for loop that says for square is 0. Square is less than 30, square plus plus. If the board position square is me, then I'm going to use that if is valid move. And what was the calling for that? The calling for that was I want to look at the board, I want to look at the player, I want to look at the move, and then what square was I on. So if that returns a true value, then I really want to return just a plus or a minus, or rather a true or a false value here. And I could just do a return 1. But once I found a value, I kind of like to know what the next thing is. So let's look at return square plus 1. Why am I doing that? I don't know. Maybe that'll be useful later on. I'm not quite sure. But I've already done the math to figure out what it would be. And so this tells me what position I could make a move from. Now, normally the array is starting at 0, but humans are going to think of that as starting from 1. So I'm going to return square plus 1 to actually say, all right, if it was the first square, then square 1, you can make a move from square 1. So I need to have a hint system. Basically, this is like saying, oh yeah, one move you could make is the first square. So if that is true, then it is going to return that as a true. Now, if it's false, then I want to move on to the next square. And so there's the if statement, and then there is my for statement. Now, if I hit the end of the loop and I haven't found any true values, end of loop, no return yet, right? I've only returned if I found a true value. Then I want to return a false value. So I'm going to return 0. Okay, that's another reason to make sure that we're returning square plus 1 up here. Is this is going to always be a true value, because if I can make a move from square 0, I'm going to return a true value, which is 1. Whereas down here, returning 0 means that it's a false value, right? So that's a way to do. It's a way to do a true-false return. And so now let's go ahead and modify our test program one more time. And you know what? Let's do it with the, let's replace the isValid move. And we're going to say, all right, let's actually pull the value here. So we're not using square right now, so we'll do square is any valid move. And what was my calling syntax for that? Well, I was going to be passing in the board, the player, which in this case is just player 1. In an actual game, I'd probably flip between, not probably, I would need to flip between 1 and 2. And then what the move is, so n moves. And then let's just print out a message that says if square is greater than 0, or I could just say if square, then printf, you can make a move. You can move that number of spaces from square that. And we'll say that's counting from 1. And so what values did I pass? I gave it the end moves and the square that it was on. Otherwise, printf, you have no moves. And in that case, you would lose a turn. So I'll probably put that in there too. Lose a turn. And let's compile one more time. And if I don't have any errors or warnings, I should get a quiet compile. There we go. And we'll run sticks. And yep, I can move 2 spaces starting from square 9. Because if you look at it, square 1, counting from 1, so the first one, I can't move 2 because that'll put me on myself. And in fact, as you look at it, I can't make any moves until I get to the last possible square that I have a starting piece on, which is 1. So as I do all of those, hey, if I throw a 0, I have no moves. I can't make a turn. So that would be that's a great way to test if my move was valid or not. So you know what? I'm going to leave it there. Having hit a 0, that's a great way to stop the video. So as you can see, we haven't finished the program yet, but we've done enough programming that we can see where this is going. So I think you can take it from here and write your own Senet program. I'm also going to finish this, and I will make sure it gets posted up to SourceForge, and I'll put a link on the FreeDOS website when that's there. So thanks for checking out this video. Before I go, a number of you support me on Patreon, and you really do make this channel happen. Thank you very much. Some of you support me at a higher level, and I wanted to thank you here. And that's it for this week. So visit our website at freedos.org, join us on Facebook, follow us on Twitter, and consider supporting me on Patreon. Thank you.